Example 3, graph parabolas in standard in vertex form. So it says graph and determine the vertex and lattice rectum. So given this, once again, we could go to graphs first, just like the previous problems, and you go to menu, graph entry, relation, and from there type in the equation just as it's given, and this should always work for you if you do it in this form to get to our equation here. And so we'll figure out what the graph should look like. So there it is, a parabola, and we could go through the menu analyze graph to find the other things. So we would need to find the vertex. So you go analyze graph, analyze conics, choose vertex, just like that, and get that point. Once you click on the shape, it should give you the point. Whoops, that just zoomed in on me. There's that point, and it also said the lattice rectum, so menu, analyze graph, analyze conic, lattice rectum. When you highlight the shape, it should show you it's 8 units long. So there's our graph. That's what it should look like. Now let's go through how you do it by hand. Notice that this is not in the form that we've been working with the parabola. We usually have the squared on the left side and the 4p on the right side. So let me now go through how we would solve this. So I'm going to first just flip the whole thing around. So I have my squared on the right, or excuse me, my square on the left. X plus 2 squared over 8. And I also have this 1 minus, and that equals y. I just flip my equation. First thing I'll do now is I'm going to subtract the 1 from both sides. So when I do that, that goes away. So I have negative x minus 2 squared over 8 equals y minus 1. Now this is dividing by negative 8. So the opposite of dividing by negative 8 is multiplying by negative 8. So that's what I'll do. I'm going to multiply both sides by negative 8. This part here cancels out all that. And so now I'm left with x minus 2 squared equals negative 8 y minus 1. Now we have our equation. The vertex comes from doing the inside lies. And so our vertex here, if x is negative 2, it becomes here positive 2. And that becomes positive 1. So it should be a 2, 1. Let's check our graph. This says negative 2, 1. Oh, it's because I messed up here. This was x plus 2. This should have been an x plus 2, which would have made this an x plus 2. So now when it lies, x plus 2. When it lies, it becomes a negative 2 here. So now we fix that mistake. Left 2, up 1. There's our vertex. And now the p is negative 8, or that's 4p rather. If 4p equals negative 8, then p equals negative 2. That means the focus is 2 points below. That's our focus. The directrix, if you needed it, would be 2 units the other way. It would be a line going through there. So I'll add the directrix here. It goes that way. And since it's going through the y-axis, it would be y equals 3. And now the width. If this is 2 units from the vertex to the focus, then it's 8 units wide at that spot. That's how you get the lattice rectum. It's the 4p value. And so 1, 2, 3, 4. I think I said 4. It's 4 times it. So 4 times 2 is 8. So it'd be 4 this way and 4 this way to give us a total of 8 units. So that's now 8 units across. I can draw my parabola around it like this. Obviously I missed on that one. But that length right here would be 8 units across. That's the lattice rectum. And that's 8 units there. And then there's your graph.